So before we get into the part of blockchain, first of all, understand what has happened to agriculture and why the digital transformation which we are talking about has become so relevant. So let's go to a little bit of history. So before the Green Revolution, typically before 1960s, agriculture was not that complex. And you'll be surprised to know that majority of farmers were profitable before the Green Revolution because the produce was very simple. So typically, for production, you used to need inputs, which used to be seeds, animal waste, farm waste, water, and human labor. So only five inputs were required for agriculture. And activities were also very post-harvest activities were also very, very simple, just typical manual cleaning. And for processing and treating and packaging, you used to use gunny bags and silos. And but while doing all those things in 1960s, even reach was limited. So typically, when we talk about perishables, it used to be consumed domestically within the region. So typically, the local consumption was there, and transportation was not beyond 100 to 200 kilometers. Now, when we talk about non-perishables, again, the markets were local, domestic, and exports. So India used to import a lot of product from all the way from US, specifically grains. So those are the example. But that time also, shipping used to take a long time, and there was a lot of food wastage happening while in the transit itself. Post Green Revolution, things have changed substantially, right? So typically, again, the input use has increased from just human beings, animal waste, water. It is now seeds, fertilizers, and crop protection. While seeds were used in past also, now the seeds you're talking about post Green Revolution were the seeds which were hybrid seeds, and in some cases, the genetically modified seeds as well. Activities has also increased post-harvest, typically drying, cleaning, sorting, aggregation, conversion also, and resources from treated gunny bags, polythene bags to silos, chemical treatment, cold storages, and transportation. Now, reach is global, irrespective of whether it is perishable or non-perishable. You can find almonds from US, kiwis coming from New Zealand, as well as avocado coming all the way from Mexico. Similarly, India's black pepper goes all the way, or processed cashews go all the way to US, and similarly, a lot of our produce goes in Southeast Asia as well as in Africa. Now, when we say that digitization is a way forward, for a very simple reason that this is a very complex challenge. The problem statements are pretty complex, and one of the reasons before getting into digitization, we have to think about the why first, because definitely digitization, just like any other industry, will lead to enhanced productivity. But because of the complexity of agriculture, where from whether it's a seeds or other inputs, it's have its own upstream value chains. Similarly, a lot of activities happens on the farm itself, and then there is a long, I'll say that very complex value chains when we talk about post harvest. This is we have to understand that the new technologies need to align with the framework of agriculture and connecting large scale companies, both input and output, with the local farmers. The local farmer is very important. So the fundamental question before we get into digitization is that why? Is what we are trying to deliver is going to help farmers, is going to make system more efficient, economical, as well as is it adding value to the end user as well as to the producer itself or not? If not, then that solution is not going to be scalable for in foreseeable future. So typically, we are seeing four technology megatrends which are shaping the food and agriculture sector as of now, and will shape the future of the sector. That happens to be big data, blockchain, artificial intelligence, machine learning, and Internet of Things. While we'll be talking blockchain in depth, I would like to cover a little bit on big data. So typically, humongous amount of data is being collected in different activities today. Even when you are having a simple smartphone, your mobile phone, you are actually pinging to the Google server and sending your location, information, usage data. So a lot of data is collected with every passing second. That's currently we are creating terabytes and terabytes of data on a daily basis, which is also having multiple facets to it, from structured, unstructured, and semi-structured data. So a lot of different type of data, whether it is video, audio, as well as text, it's all there. Blockchain, definitely, as I said, you were talking about it. Now moving to AI and ML. So when you are having so much of data, what do you do with that data? So one thing is that use that data to simulate and use artificial intelligence and machine learning to convert that data to actionable insight, which is not humanly possible. So for human beings to have a look at 208 different parameters which is required for growing a crop, it's very difficult, but machines can do it far better than us. And the last but not least, Internet of Things. So a lot of data is being collected through sensors on ground, which are connected to the typically internet. And that data is also used in AI and ML to deliver value. Now, as I've left the blockchain, so you have to understand blockchain is the biggest technology megatrend impacting productivity in agriculture. Now, the reason I say that is for a very simple reason that blockchain is having its own ways and means to improve what has been happening in agriculture. So there is a very good synchronization of the value proposition of blockchain and agriculture. So if we go a little bit in the history of blockchain, it is biggest disruption after internet for a very simple reason. It make decentralization of the trust. So though I don't know who is Mr. Satoshi Nakamoto, whether he's a human being or whether he is a group of people or individual, there is a paper written by him in October 2008, which was typically about peer-to-peer electronic cash and digital asset lending. So that is where actually the genesis of blockchain, and typically that was eventually led to a cryptocurrency called Bitcoin. So generally people, when they think about blockchain, they directly connect that it's a Bitcoin. No, but blockchain is not a Bitcoin. It is typically a technology which backs Bitcoin. There are other popular blockchains as well: Ethereum, Cardano, Binance Smart Chain, EOS, or IBM Food Trust, which is more relevant to agriculture and food sector, to name a few. As I said, blockchain is not a Bitcoin, but its origin lie definitely in Bitcoin. Now a lot of people say blockchain is a new technology. Now Bitcoin has been there for more than 10 years. Now a technology which is there for more than 10 years, right? It has to be tried and tested and old technology. While we always talk about a lot of frauds happening in cryptocurrency, but it is not because of the lack of technology capability. It is of people not having wrong intention. So it's just when we say that cash is a successful way of doing transaction, but if there is someone who is having wrong intention and he robs a bank, then you cannot question the cash, right? You question the intention as well as the bank itself. Similarly, blockchain is very robust technology, tried and tested. There has been not a single case of hacking into the Bitcoin's blockchain, right? Similarly, when we talk about Ethereum, there have not been cases where actually the breach of the blockchain has happened. But yes, people have fooled others by saying that they're on the blockchain while they have a simple database, and then they manipulate it. So majority of the stories you are listening about, frauds happening in cryptocurrency, is not because of the technology. It is of people being not careful when they actually do a transaction on a system, or when they start believing a typical platform without knowing about the platform. So typically Bitcoin is nothing but it is bank of internet where everybody is anonymous. There is no central reserve bank type of thing where who decide how much currency to print and how much currency to roll. It is having its own algorithm, and only limited amount of Bitcoins can be created over a specific amount of time, and everybody who validates those transactions typically is allowed to keep or retain a part of the value being generated. For every transaction, you'll find that in Bitcoin, there is a validation which happens, which is known as data mining, and that all the data miners also get a part of piece of the value generated in form of the Bitcoin itself, a partial Bitcoin itself. So typically, blockchain is nothing but an infrastructure upon which the Bitcoin rests. Every 10 minutes, there is a new block which is added by the miners on a Bitcoin blockchain. So typically, this is what Bitcoin and blockchain relationship is all about. Now let's understand how the blockchain works. So for example, there are multiple people who are part of the blockchain network, and then someone requests a transaction. So the requested transaction is broadcasted to all those who are typically peer-to-peer connected to the blockchain network, which typically consists of computers and or which are known as nodes. Now these computers can be a computer itself, like laptops or desktop, or it can also be a mobile device or any device which is having computational power. So from there, actually, what happens is that once that the transaction is broadcasted, there are people which are, as I said, typically known as miners. They would be running the algorithm to validate a specific transaction. So some of the network of the nodes will validate a transaction and use a status using these algorithm. Once these miners validate the transaction, the transaction is added to existing blockchain as a part of a blockchain node, as a part of the blockchain as a block. And any block is actually connected to the previous block and the subsequent block. So that makes blockchain immutable. And once the block is created, the transaction is recorded and the whole transaction is completed. Now let us understand, what this distributed ledger technology is all about. So it is nothing but a simple database, but it is distributed across the network. So typically on internet, and everybody who is a part of that network would be having a copy of it. It is auto-synced, so every copy is same, always instant. So the blockchain information or transaction information on my node would be similar to anyone else's node who is part of that network. It is encrypted, so all blocks are encrypted with the private key. So anybody who create a transaction would be writing it through private key, and those who validate it would be doing it through their private keys. And finally, anybody who's having access with the public key can see that transaction. So it is immutable, so no transaction can be deleted. Now, reason it is not deleted, you can see on the right side, there is a diagram. So you can see that the block 52 is having a reference of a previous block 51. So if you see the proof of work, and then below that there is a previous block. So the proof of work of previous block is connected to, or like, is embedded in a block which is the subsequent block. So similarly, block 53 is having a reference to block 52. So now, in case you want to do any change in block, for example, 51, it is nearly impossible because it will be connected to block 50. Similarly, like, if change need to be done in block 52, it is impossible because it would be again be having a reference to block 51. So individually, like, you cannot change or like, delete any transaction. Commonly, it is open and public, so everyone authorized can add the blocks, and it is consensus based. Ensure only one version of truth is there. Now we are having various ways of typically, like, configuring a blockchain. So the most common one is actually permissionless public distributed ledgers, which is at the bottom. And the most stringent, which is typically used by corporate, is permission private distributed ledger. So in permission private distributed ledger, the transaction is limited to predefined set of nodes. So that means it is private. And the validation and writing of the blocks is granted by the central authority to a predefined set of nodes. So here you can similarly treat it as like, the central bank, Reserve Bank of India, which allows who is able to validate a currency. The same way, like, the private blockchain, which is permission, works. The next configuration is permission public distributed ledger. So anybody, that means having a computer or write software, can access the blockchain, but the validation is only done by a handful of the people who are allowed by the central authority. The third type is permissionless private distributed ledger. So here again, the people who can access the blockchain network are limited, are private, which are allowed by typically based on predefined set of nodes. While anybody who is actually part of this network can validate. So that makes it permissionless. And finally, typically the example being any of the cryptocurrency, that is permissionless public distributed ledger, that anybody can, who's having a right software, can typically broadcast a transaction on the blockchain, and anybody who is allowed, right, to be on that network without any permission can actually, like, validate those transactions. So this is typically totally anonymous. It is something which is totally public, and there is no permission required. And as I said, the examples are cryptocurrency. Now let's talk a little bit about something a little bit more embedded, which is having more capabilities, which is Ethereum or the smart contracts. So when we say Ethereum, actually it is a blockchain platform that supports a further evolved version where it can be used for development and deployment of decentralized applications and smart contracts. Now, smart contracts is nothing but it's just like a simple contract which you do in a physical world with all the parameters which are codified. And all the parties who are supposed to be the signatory of the contract, they are part of this blockchain or Ethereum network, and then they validate and they sign it using a private key, hence making the contract, like, typically enforceable. It was launched in 2015 and is one of the most prominent and widely used blockchain platforms currently. We have to understand that this is a general purpose blockchain, and it is not exclusively designed for food and agriculture. But however, it can be utilized in agriculture as well, just like any other industry. So why Ethereum? So smart contracts, it enables the creation and execution of smart contracts, which are self-executing agreement with predefined rules and conditions. Decentralized application can be actually, like, deployed on top of Ethereum blockchain. Then we are also having a lot of Ethereum virtual machines. So it can be like, you can download your own virtual machine and you can run it on your own machine, typically computers, right? So you can create your own blockchain network without, like, depending on a public cloud. It is ERC standards, which are typically nothing but Ethereum request for comment statement. And this is these are standards which have been, like, typically defined by the Ethereum itself. So you can work around those rules and protocols so that actually the solution which different people are building, if they are following the same ERC standards, they can interoperate with each other easily. So as I said, that, Ethereum can be base of application for blockchain in agriculture. So as I said, it is not specifically tailored for food, but it is having a lot of value addition, specifically when we talk about smart contract, which is very relevant when it comes to agriculture. For example, like, when we talk about supply chain or like, for both on input and output side, whether we talk about the monetization of agriculture data, validation of IoT data, or like, multi-party agreements, when we talk about cross-border trades, somebody export, all the documents required for that can be the part of this smart contract. So typically, like, Ethereum, if used in agriculture, can provide transparency, traceability, and decentralized governance. So as I said, there are some other alternatives as well. So Binance Smart Chain is a blockchain platform developed by cryptocurrency exchange Binance, and it offers fast and low-cost transactions, making it an attractive option for developers and users. BSC is compatible with Ethereum, allowing developers to port their Ethereum-based project also. Then the Cardano is another very popular platform that aims to provide a secure and scalable infrastructure for development of decentralized applications, smart contract. It is actually emphasizes on academic research, formal verification, and layered architecture to enhance security and sustainability. Solana is another high-performance blockchain because actually it has cubed its architecture a little bit, more suitable for decentralized financing because they need fast transaction processing, and rather than proof of work, it goes on proof of stake, which reduces the total time required for validating a transaction. And similarly, Avalanche is a platform that combines the benefit of scalability, security, and decentralization. Again, it is having very high throughput, quick finality, and low transaction fees because you don't need too much of GPUs for it, because again, it has an algorithm which makes the validation not as evolved as which is required for example Bitcoin, which is mining. So it includes usage in agriculture as well as in distributed finance and supply chain management. Tezos is another self-amending blockchain platform that enables on-chain governance and formal verification. Now, this is very important because this is heavily focused on security and upgradability. And when we say security, when we talk about the food safety, Tezos can provide a very valuable option. And EOS is another platform that aims to provide high-performance scalability and user-friendly deployment tool. It offers a delegated proof-of-stake consensus mechanism and support the development of decentralized application. Now, you'll hear these words proof of work and proof of stake regularly. Proof of stake doesn't need too much of computing power, while proof of work needs a lot of computing power. Both have their own pros and cons, and depending on what application you want to use it for, you can decide which type of blockchain you can use. Now, these are some of the actually blockchain application which can improve the agriculture productivity. So IoT and open data. So you'll find that IoT data is unsecured. So all the zeros and ones which are transmitted from a sensor to the cloud, the security becomes an issue, and anybody who can breach into it can really create a lot of problems for those who are using this solution. So if you align IoT or open data with blockchain, you can provide a layer of security, which is very, very important. Blockchain can also be used for farm monitoring and management, where you can have different stakeholders becoming part of the blockchain network, and then they can work in an environment of decentralized trust. Trade and supply chain. So specifically when we are talking about cross-border trades across countries, documentation using smart contracts make it very fast and easy, and it ensures that you are able to conclude the transaction in a very, very reduced fees. Payment and transaction itself. So typically, when we are talking about the banking, whether it is about delivering credit to supply chain players or the farmers, all of those things can be ported to blockchain and can reduce the cost of transaction, which is very important. Subsidies and incentives. So there are government policies actually whether the compliance is met or not, right? Or delivering certification. So when we say that compliance and certification, it also ensures that government policies using smart contract can be delivered without any paperwork required from either the end users, or typically the producers or the supply chain players, or the government. So that makes delivery of government incentives trustworthy, transparent, as well as economically more efficient. Now, the agriculture productivity and food safety is a global challenge. So we are talking about typically 821 million people were food insecure in 2020, and the last data which recently was published by FAO, we are talking about close to 1 billion people who are food secure today. And by 2050, we'll be having population of 9.7 billion, and that's typically more than 2 billion added since last year. And 30% of food produced goes to waste due to the inefficient value chains, and that leads to a loss of $1 trillion. Contaminated food causes 200 plus diseases, and 700 million people fall ill every year because of contaminated food, out of which 500,000 die due to unsafe food. Cost of unsafe food due to medical expenses and productivity losses is $200 billion. So now this will give you depth of the importance of food safety and security and why it is a global challenge. Now, what are the bottlenecks for agriculture productivity? First is productivity data collection measures adds to hours and dollars. So typically, nobody wants to collect a lot of data, right? So if I tell you, for doing a specific activity, you have to feed so much data on your mobile application, and then you commence it. Not too many farmers will be doing it, or even the people who are in the value chain would not be very keen to exit. So productivity data collection is costly. It takes hours and dollars. The more complex the value chain, more paper trails and more documentation. aggregation and quality assurance at different stage a bottleneck. So typically, like, you won't be having all the testing tools or quality assessment tool at all the stages. So that makes it different. Tracing the source of contamination or deviation difficult and costly. So you cannot trace back actually from where, in case you have got a bad product, right? For example, a bad apple, you don't know exactly when actually, like, this creeped into the value chain, who have been the actual supplier, because aggregator would be taking it for hundreds of farmer, and a wholesaler would be taking it with hundreds of aggregators. And when it comes to you, like, that aggregator would have sold to hundreds of retailer, who would have sold to hundreds of shops, and then it coming to you. So finally, tracing the origin of any contamination is very difficult. Logistic can be a critical spoiler, especially for control environment transportation. Because, for example, like, if you're in a control environment containers, what we call refrigerated containers, right? A product move. If the refrigeration was not working for 1 hour, right, you'll never know. So once actually product is delivered to you, it is of substandard quality, then you come to know that there is something wrong, but you cannot actually point it back that it is the logistic which lead to this, typically, like, contamination or spoilage of the food. Difficult to regulate and enforce compliance. That has always been a challenge across the world, where actually, like, to work on compliance, right, is always a non-scalable, I'll say that, or easy to execute area. So why blockchain in agriculture? So all the problems I talked about in previous slides, right? The blockchain, in short, provides you traceability, it provides you immutability, it provides you transparency and efficiency. Now that solves many of the problems of food safety and security, as we, like, just mentioned before this slide. Now, this is how typically a digital, like, architecture work in blockchain application. So you're having farm data coming from IoT, satellites, drones. Then there is a publicly available data on public clouds. Then there is a proxy data, which could be on the public or a private cloud. And then the transactional data, typically traceability data and the blockchain-based transactions data. And all of that goes into big data engine. Either it can its own create actionable insight, or then you use AI and ML tools, right, to create more value and actionable insight, which are provided to the different stakeholders. Now, these are some of the blockchain application in agriculture and food sector. So food safety, ensuring the food to plates is grown in a sustainable and is traced end-to-end from farm gate to the fork. Remove counterfeit, especially this works more on when we talk about agriculture input, because a lot of counterfeits agriculture input, whether seeds, fertilizer, pesticides, high cost inputs are, like, their duplicates are being produced. Risk mitigation, empowering farmer using, giving them the right sort of insurance or risk mitigation tools, which are parametric insurance, can be done through blockchain. And then the data monetization. In future, we might see that farmer will not be only having a revenue stream by selling their agriculture commodities, but we can also sell their data. So these are some of the agriculture-centric blockchain platform and protocols. So IBM Food Trust, so it is developed by IBM. It is actually aim is to improve food safety and traceability, and it enables participation in the food supply chain, such as farmers, suppliers, manufacturers, distributors, retailers, to track provenance and movement of food produced in a real time. The provenance itself is a blockchain platform that focuses on traceability and transparency in supply chain, including food and agriculture. It allows consumer to access information about the origin, ingredients, and process involved in production of the specific products. Even if there are multiple producers that are involved, that can be done. Next is AgriDigital. So AgriDigital is a blockchain platform that specializes in agriculture supply chain, particularly in the grain industry. It offers features such as digitized contracts, secure payment, transparent inventory management to streamline transaction, mitigate risk. Origin Trail is another, which actually is focused more on, like, ensuring that the integrity of information and facilitation trust between different type of stakeholders involved in agriculture value chain. So in my view, blockchain addresses some of the key current challenges of agriculture, including lack of information, poor transparency, inefficient value chains, and severely limited access to resources. This will lead to enormous improvement in productivity of agriculture while making world more food secure and the sector as a whole more environmentally sustainable. Now let's understand a little bit about, like, another problem which is solved by blockchain, that is on the input side. So if you see that agriculture input ecosystem, like, it relies heavily on, for example, like, when we say agriculture, it depends on seeds, fertilizers, pesticide, machinery, etc. And 50 to 80% of total cost of cultivation is agriculture input. So agriculture input market consists of producers, manufacturers, carry and forwarding agents, distributors, and multiple level of retailers, with farmers as an end consumer. So retail are not just the point of sales; they supply also. They give a lot of information, and they are providing inputs to farming community on parcel of practices, what needs to be done, and any infiltration is there, but farmer goes to the retailer first. Farmer globally have been facing issues like lack of quality fertilizers, pesticide, and seeds, inefficiency in supply of inputs, spurious counterfeit and illegal product, pricing frauds, lack of information on usage of the inputs, etc. So these are some of the challenges when we talk about the agriculture input ecosystem. Further, as the supply chain is highly regulated and dependent on paperwork and data, it creates another level of bottlenecks. So lack of supply chain wide data hampers complete analysis of supply chain leads to inefficiency. Now, this is the challenges we are seeing from the typically the value chain player perspective, not the farmer perspective. Unpredictable demand depends on many factors, making inventory management difficult. Diversity in cropping patterns make product placement and availability a key challenge. Lack of decentralized information and communication tools, lack of verifiable authenticity given rise to counterfeits and fraud. And business among players is usually limited to people you know personally and trust. Now, what are the typical objective of any input ecosystem? It has to enhance definitely crop production, promote sustainable agriculture production, improve profitability of the farmers, reduce public and occupational health hazard, meet obligation under international convention, efficient chemical life cycle management, minimize negative environment impact, ensure compliance and better informants, and eliminate illegality and malpractices. Now, this is where actually you find that the counterfeits, they are the biggest threat, because 25 to 40% of the pesticides sold in a developing country like India are illegal, substandard, spurious, and counterfeit. Now, this lead to the farmers suffering heavily because they might be believing they have applied the right inputs, but they don't get the result, leading to lower yield or crop failures. Sometimes even lead to total devastation of their farmland. And similarly, it creates a lot of problem to the other value chain player, including the manufacturer and the brands, because the farmer loses trust in the brand itself because he would have used a counterfeit. Now, counterfeit can be countered using blockchain. Why? Because blockchain provides traceability, immutability, transparency, efficiency, programmability, scalability, and privacy. Now, the use case for counterfeit is factory to gate traceability. So factory gate to farm gate traceability and regulation and compliance management. So these two key problem statements can be solved using blockchain when it comes to the agriculture ecosystem. So trying to make input supply chain more trustworthy and efficient and transparent is what is the key, I said that value addition by blockchain. It helps in digitizing the supply chain and helps in tracking data for product throughout the network. So as soon as it leaves the factory gate to the last used by the farmer, it can be traced. It is the power of technology to make data sharing possible among players who have conflicting interests in the supply chain. So definitely the C&F is having its own conflicting interest than the producer or similarly retailer. So everybody can be given only that part of data which is relevant to them. A unique advantage of openness, security, and trust help in fit in input supply chain where multiple competitors are fighting for the same market share. So for example, if you are having a marketplace, we are having multiple competitors providing their product. All of them can have only access to their data. For example, a same retailer can be selling 100 of product and his data is on the blockchain. Similarly, the producer can only see that data of his product being sold by that retailer. So that level of minute micromanagement can be done using blockchain. So let's see how a blockchain-based factory gate to farm gate traceability works. So manufacturers labels the product with the identifier, for example, QR code, RFID, or smart stickers, and register on the supply chain to start the product journey. The product is transferred, initiated on the blockchain once the current owner initiated transfer to the new owner. And the new owner, is, for example, could be a C&F, a dealer, a distributor, or a retailer. And transaction is completed once the receiver scans the product, identifier once received the product, and all of that is actually done through blockchain, where a block is created of every transaction. All the data of the product journey is collected and stored on blockchain in encrypted format. All the players have web and mobile application where they can view the data and analyze their part of the supply chain. So they only see what actually is relevant to them. Further, overall data can be aggregated to gain insight into complete supply chain. These data parameter exposes for the analysis, which can help in decided by the consensus, which can help in further improving the efficiency and effectiveness and economic viability of the whole value chain. It can reduce the cost drastically. So typically, what are the benefits of enabling blockchain-based supply chain? Automating the purchase process, improving transactional flow, securing supply chain, ensuring integral geotraceability, detection and prevention of frauds, streamlining and maintaining internal documents, and inventory prediction and forecasts. So these are some of the benefits of using a blockchain. So I'll be talking this in a little bit of brief. So value addition to supply chain is that actually you can reduce the cost. You can make the whole transaction digitized. You can ensure that there is always a proof of a specific transaction, which in case there is a problem, can be always referred to. A smart contract can ensure that the movement of product as well as data is on a real-time basis and not too much time is wasted. And hence, overall efficiency and transparency pays ways to price reduction of the product. And hence, it also helps a farmer. So for supply chain participant, whether it is manufacturers, C&F, distributors, retailers, or farmers, everybody gets value. I'll talk a little bit more on the manufacturer. So he gets a visibility of a complete supply chain till the farmer. Data is helpful in weeding out the player who indulge in mixed fraud. So typically, when you say that somebody is doing a fraud, the manufacturer can always identify, trace it back to who are those retailers of C&F or the distributors who are doing any sort of fraud. Data is helpful in inventory management and predictive analysis or demand on geological level. So you can pinpoint to every specific location that where the value chain is not efficient, what fine-tuning is required, whether it's a logistic problem, whether a C&F is not doing work right today, whether distributor or retailer is not actually ensuring the right practices. Similarly, farmers can check the authenticity of agri input. I think that is very important. So typically, a farmer can just scan with a QR code and send that information, and on the blockchain, it can be referred. And once a transaction is validated, you know that actually the product you have bought is not a fake. Get expert insight with the agri input historical data from the network, and more efficient supply chain means economic product for the farmers. Now, when we talk about blockchain-based regulation and compliance management, so if you see that typically the regulation have three pillars: transparency, trust, and traceability. And I've shown you in previous part of the presentation itself, these are also central to a blockchain. So compliance through a blockchain gives you a holistic framework for enforcement of policies in coherent manner. And it's always like, good policy is great only if it is implemented well. And blockchain ensure that those implementation happens. I'll just give you one example. There are close to 40,000 cases pending with the regulators for allowing biostimulant and bionutrients, right? And that processing is taking humongously long time. And typically, one registration in India takes 6 to 7 years, right? And in the current world, just think about, you have come out with a very novel product and it takes 6 to 7 years for you just to get a regulatory clearance. Like, that reduces the possibility of using innovation in agriculture. So these type of problems can be resolved when you are having compliance and regulation based on a blockchain. So how the blockchain-enabled compliance network works? So product, regulator, enforcers, intermediaries, retailers, and farmers all can be on that network. An application can be product management, SKU level management, transaction management, entity management. So regulator can see all this information on real-time basis. And in case they have to pull out a product or they have to restrict or ban a product, they know exactly where that product is. And based on that, they can ensure that, if they have to take any measure, they can make it and do it in a very real-time basis. Our compliance pain point, which are addressed by blockchain, is high cost of administration. So reduces compliance costs for all the stakeholders by 50 to 80%, lack of accountability. So it ensures through decentralized system that every stakeholder is accountable. So for somebody who's sitting for for 2 years on a file, is not clearing it, it would be visible. And because he has to using his private key, right on the blockchain itself, that he's approved or rejected. And what is the reason behind that? Lack of resources. So because it automates a lot of processes, blockchain ensure that the lack of resources doesn't leads to inefficiency in the compliance network. Difficulty in enforcement of compliance. Again, as I said, that all the stakeholders can be part of the blockchain network, and on real-time basis you can have the data, and using right dashboard you can ensure that the enforcement can be very productive. Now, another use cases for agriculture is output to ensure food safety and food security. So here, farm gate to fork traceability and global food trade transparency, which again I've explained earlier in this presentation itself. So when we talk about agriculture output, farm to fork problems are food safety measures and provenance difficult to achieve, complex paper trail and documentation, quality assurance at different stage of bottleneck, visibility across value chain, including actions, logistics, storage, condition monitoring, and difficult to regulate and enforcement of compliances. So how do we make food value chain more trustworthy and efficient and transparent? Again, as I said, by having all the different stakeholders on the part of the blockchain network, because it digitizes commodity value chain and helps in tracking data for the product throughout the network. So exactly you know the origin and the end usage of that specific product. So these are some of example of how it is of existing deployment, how it is working. So for example, Carrefour provides the data to the shopper. So shoppers trace quality and origin of antibiotic-free chicken from production through distribution via QR code scan. A coffee platform transform industry. So coffee farmers platform enables the consumers to learn about their coffee journey and the ability to donate to the coffee farmer. So this is already tested in multiple countries, including Ethiopia. So if you are just scanned, in case you want to pay to the farmer who has grown that coffee which you are drinking or you have purchased, right? You can straight away remit money to him. Walmart, is using it for leafy green safety. So they have asked all their leafy green supplier to ensure instantaneous tracebacks in the event of food recall. Again, it is based on blockchain. So GSF is another for tracking of freshness of beef. So track, trace, and monitor fresh beef throughout the supply chain with ERP, RFID, and IoT temperature data. Again, this is also based on a blockchain. So how the decentralization of supply chain typically works. So if you see that on left hand side, you are having the current method, typically supply chain, where restaurant can buy from a manufacturer, from the growers, from an import or a logistic company. Similarly, or a retailer. Retail is a center. Again, he can directly buy from the grower, or he can directly serve to restaurant. So there are too much of complicated. I'm saying that haphazard supply chain. Now all of these can become the part of the nodes of a blockchain, and then you can streamline that whole value chain very easily, where all the data is stored coherently on the blockchain, and only that data is made available to you, which is relevant to you. So for example, grower can see that actually who is buying his product, and then there is no problem of the trust, because trust is decentralized, it is taken care of the blockchain. So grower can sell to any retailer, can use any logistic supplier, and similarly the input provider can deliver to any grower, and all of that information can be a part of the blockchain. And further, it can be through smart contract ensure that everybody who is part of the network typically have no I'll say that backing out of a specific contract. So this is a typically blockchain-enabled agriculture output supply chain. So growers, they share and prove the point of origin, prove sustainable and ethical growth practices, improve brand trust, and strengthen customer loyalty. For food manufacturer, it improve brand trust, strengthen customer loyalty, see the manage inventory in real time, monitor dwell time, share records with the other supply chain partners. Wholesalers and distributors can manage inventory, track and improve freshness, monitor dwell time, real-time inventory management, and conduct targeted recalls. Food retailers, for them, it improves brand trust, strengthen customer loyalty, grow revenue, extend shelf life, reduce food wastage, conduct targeted recalls, etc. And then for food logistic companies, they can see and manage inventory in near real time, track and improve freshness, monitor dwell time, real-time inventory management, and comply with new regulation and efficiency wherever they come. So blockchain address some of the key current challenges of agriculture value chain, both upstreams and downstream, that is for input and output. This impact multiple aspects of food economy in general and agriculture in particular, as from food safety to food security to cost of food produced can have impact of blockchain. With that, I would like to end my presentation, and I'm available for any questions if you have it.